Hi, my name is Thijs.
And I'm Marianna.
And welcome to part 2 of this 3-part video series about the Massive Storage Engine version 3, or MSE as we call it. Did you miss out on episode 1? Don't worry, there's a link at the right upper hand corner. If you click it, it takes you directly to the first part. But in this part, in part 2, we'll primarily be focusing on persistence, on cache persistence. Ariana and I will explain you how it works and how it's implemented in MSE, and we'll also show you how you can use it to spread your content across multiple storage devices. We'll also show you how MSE's persistence layer can serve as a secondary origin, and we even have an example configuration for you. Near the end of this episode, we'll also share some insight on why we prioritize performance over persistence.
Memory is limited in size and it won't survive over restart. Which means that if you need a big cache and you need object to survive over restarts, you might want to add a second layer to this MSE file, where we're going to define a book and one or two or more stores. A book is a high-performance database where we're going to store the metadata for each object, which contains either the hash, the TTL, or the vary matching. While the store itself, it is a large pre-allocated file. In order to glue everything together, we need to run this mkfs msc command and point at this configuration file. This command will make sure to create, in this situation, two different files. And we're going to create store 1 and store 2. Objects will be inserted on this store using a round-robin fashion.
Keeping books and stores on separate storage devices is useful when disks may not have the same I/O capacity. It is advisable, for example, to store the books on fast SSD type storage while using the larger but slower rotating disks for stores. The fact that multiple stores and books are supported allows you to distribute your cache across an array of storage devices. Not only does this form of cache persistence offer you disaster recovery, it also enables you to warm up the cache on a separate machine and mount this store with hot data.
As we can see from this configuration file, we first of all need to define an environment and give it an ID. We're going to call it my environment this time. We also need to define a memcache size, which defines how much memory we want to use for any caching related scenario. Also, in this same configuration file, we have decided to define two different books, book 1 and book 2. And each book will use two different stores. And each store, or better, each cluster of stores will allocate objects following a round-robin fashion.
When the memory of your Varnish instance using MSE is full, the previously mentioned LRU eviction mechanism will remove the least recently used objects from memory while still keeping them on the disk. When the evicted data is requested again, it is directly served from the disk cache rather than fetching it from the origin. One could say that the persistence layer serves as a secondary origin. The design principles of MSE favor performance over persistence. And this makes sense because Varnish Enterprise is a cache. It can cope with data loss by revalidating the content with the origin server. On the other hand, Varnish Enterprise positions itself as a high concurrency system that can process up to 100 gigabits per second on a single machine. This means that performance improvements are always a top priority. The Linux kernel, however, is not optimized for caching and has to cater to many use cases. A lot of systems offload low-level logic to the kernel for the sake of convenience and for separation of concerns. In our case, and for these reasons, offloading all of this logic to the kernel for MSE does not make sense. Thanks for watching part 2 in the third and final part of this video series about Varnish Enterprise's massive storage engine. We'll focus a bit more on the limitations of the operating system's kernel in regards to caching, and we'll show you how MSE can cope with them. We'll show you how we re-implemented the page caching mechanism in user space. We'll talk about memory bookkeeping and journaling, and we'll even show you a couple of limitations on the file system level and how MSE's implementation avoids disk fragmentation. And we'll end with a quick recap and a glimpse into the future. All of that in episode 3.